Hi everyone, and thanks to the organization for having us here. I am Filippo Calcerano, and she is Letizia Martinelli of the National Research Council of Italy, of the same group of ENI CBC. And today we will be looking at the improvement of built heritage from an environmental design point of view with the support of digital technologies. So, first things first, cultural heritage plays a key role in many of the 17 objectives of the Sustainable Development Goal agenda, so to be considered by some scholars the fourth dimension of sustainable development. And this role is increasingly supported by a number of other reports and entities. And obviously energy consumption and climate change are an issue also for the built heritage sector. And an issue in terms of aggressive environment and risk assessment, but also in terms of reduced usage of buildings, which is jeopardizing the usage, it's jeopardizing their conservation. And historical buildings are not the most numerous nor energy intensive sector of the building industry, as they generally behave more efficiently than the building constructed between the World War II and the 80s, because they are optimized for the reference climate. But climate change is weakening this assumption by undermining the natural functioning of historical buildings, with significant consequences on their conservation as well. And it would be so necessary to develop increasingly advanced methods of adaptation to climate change in order to enhance their resilience. And obviously, in addition to vulnerability, there is also this issue of energy consumption, because now and in the future it needs to be addressed from a conservation and valorization perspective, so avoid fuel poverty and thus building abandonment, and from a sustainable development perspective to reduce consumption and emission and help mitigate the causes of climate change in the very long run. And so, how to do so? Well, despite the EU, as was Elena saying, being an early mover on these themes, also from the building sector, coordinated action is still lacking, and Climate Heritage Network, that probably is one of the most active network on this issue, released its European Heritage Green Paper to assess the role that heritage has or should have in relation to the European Green Deal that's not very sensitive on this matter. And the potential of this study is really high, especially in Europe, in the past with a lot of studies of risk assessment, and now we are starting to have also adaptation and mitigation. And the Italian scientific debate, in the wake of what has happened in the structural analysis field, now is using the concept of improvement for the energy and environmental intervention on built heritage as a valorization and protection strategy subordinate to their conservation. This approach involves the compliance with the guiding principle of international restoration charters and provide at least 4 fundamental advantages that could be disciplinary cross-fertilization, added value of knowledge, big on for the sector, and technological stress test. The connection between cultural heritage and the environment, probably anticipated by John Ruskin, was present in the UNESCO Charter of 1972 and reinforced in the Aalborg Charter of 1994. And environmental design and conservation share many methodological aspects, from the transgenerational time perspective to the need to use multidisciplinary, holistic and multiscalar approaches, and also the need to move in the space of uncertainty in the border between hard sciences and humanities, which provides us possibly with the most interesting insights. For example, from the conservation theory, where scholars argue that the division between cultural and technical aspects does not exist, and that the building must be studied as a complex system that cannot be analyzed by parts. So, in a way, allowing us to have a compass for applying and introducing innovative technologies and methodologies on historical buildings. In other words, deterministic approaches on heterogeneous buildings with high levels of uncertainties should nevertheless be included in the science reasoning process to pursue the best possible rational formulation of a problem in terms of data, hypothesis, and interpretation. Another aspect concerns the natural historical buildings that, being optimized for their climate, are also a source of ideas for contemporary architecture. And not to mention that the study of the bioclimatic behavior of built heritage provides an added value of knowledge thanks to the possibility of reconstructing the natural functioning processes while enhancing their distinctive characteristics linked to the local microclimate that its use can use also for energy efficiency, okay, but also for conservation, as for example, sun and wind strongly affects also decay processes. And the third aspect concerns the European Directive 2031, which emphasizes the role of public administration as an example in the energy efficiency of the construction sector, and historical buildings as symbols of European cities, if not of Europe itself. So a true beacon reinforce this role, as also underlined by the project that we are seeing today. And finally, the complexities related to those interventions, of which we will get a taste later, makes a historic building the most demanding experimental laboratory ever to test new technologies, approaches, and their scalability. So that's why the stress test. And now on to the technologies that we believe are key right now to support this kind of intervention. I leave the floor to Letizia Martinelli.
So now I will talk about the digital technologies that we are applying for supporting this energy and environmental improvement of historical building, and especially simulation-based design and building information modeling. So as Elena Giarelli was saying before, building performance simulation is based on the definition of a model of a building where the physical entities of the real world are reduced to a certain level of abstraction. And this abstraction, this simplification, help understanding and analyzing complex phenomena, and also ensure feedback on the effect of design choices on buildings. And this is very, very important and very promising for analyzing the effect on historical buildings. Not just from an energy point of view, but also from a conservation point of view. For example, for analyzing decay phenomena. Problem is, these technologies are still not widespread because of their general complexities, and also, as Filippo was saying, their complexities inherent to historical buildings. Because simulation models are based on simplifications, and historical buildings are generally not that simple from a lot of points of view, from the geometric point of view, from the point of view of a heterogeneous constructive system maybe developed over time. There are problems with the construction of the buildings. For example, not all simulation software can well represent massive behavior, very thick walls, and also the importance of moisture transport that is key for analyzing masonry. And in general, the scarce diffusion of these tools in the architectural sector and in the conservation sector. BIM is the other technology that Elena was also describing before, and it's defined as the digital representation of the physical and functional characteristics of a built asset. What is really important for us from the point of view of energy and environmental improvement is the idea of an information system. So a BIM model comprises a 3D model of the geometric information on building components, but also on properties and relationship among components. And this idea of the information system and the repository of information is very important when dealing with historical buildings that normally for their conservation, documentation and valorization, they require a huge amount of analysis and data. Okay. So the heritage BIM, the BIM applied to historical building is very, very important to enhance their conservation. And these are some of the activities that can be developed within a BIM model. A BIM model is never, well, almost never a single model, but is a constellation of different databases connected among each other. And so all this information then are combined to define the representation of the building. And what is important in the field of energy and environmental improvement is also the idea of the digital model as a simulation to study the behavior of the building in certain conditions. And so BIM models and simulation models, they, depending on the uses of the BIM model, they shared a lot of data. For example, data on the envelope, data on the spaces. So an interoperability process between the two environments could help save time and reduce the risk of errors. However, this interoperability is, well, is still under development and is very, very complex to achieve. Not just because of the simplification and assumptions that are needed by the energy modeling that are different from the structure of the BIM model. For example, a wall is represented in the BIM model as a volume, while many simulation software have a two-dimensional representation, but also, again, it's linked to the complexity of historical buildings. So there are interoperability issues, go from geometric issues again, but also issues in the sharing of alphanumeric data. And therefore, there is still the need to define semi-automated or manual approaches to map the data flow and define clearly what data should be shared by one software to the other, and also how to check if the data that is needed is well shared. And this is a multidisciplinary process, as Antonella was saying before. So the most important thing is that all the experts that are involved in the process, the simulation experts, the BIM expert, but also conservation and restoration expert, should work together. And therefore there is still the requirement of a preliminary feasibility study for the interoperability to define a shared knowledge framework, to define which data should be passed from one software to the other, and then to perform interoperability tests, from very simple models to very complicated ones, in order to have a protocol of data sharing that can help each actor of the process to work inside his comfort zone, let's say, so inside the software in the best possible way. So very fast, because Ellen already showed that, this is the application of this approach to BIP workflow. So there is the first phase is data collection, geometric data, but also environmental and energy analysis. That is then goes to the BIM platform, so to the BIM model. That is then the BIM model of the building as is. That is then exported to the simulation software, calibrated and simulated. At the same time, design solutions are developed, simulated, and also analyzed for time and cost constraints in order to find the best intervention scenarios possible. And you'll see some results of big project. You've already seen some. And this protocol that was defined within the results of big project has been published as a preprint in Zenodo, that is an open-air repository for documents and researches, and we will love to print it as a book in the near future. So thank you very much. And